A Chinese humanoid robot just stunned the world. It threaded a needle, then stitched delicate embroidery, live on stage, something even experts once believed robots would never master. And here's the wild part. Robots aren't just lifting boxes or beeping in warehouses anymore. They're learning fine, human-level skills, the kind perfected over centuries. When you picture a robot, you probably imagine a metal arm bolted to a factory floor, repeating the same motion over and over. That's how robots used to work. Hard-coded instructions, rigid loops, no real understanding of the world around them. But something has changed. We've reached an inflection point. Robots aren't just being told what to do anymore. They're learning to see, think, and act. Artificial intelligence can now connect vision, language, and motion into one unified system, not separate modules. One brain linking perception directly to action. Imagine teaching a robot the way you learn a skill. You show it once or twice, and it gets it. That's the power of vision-language-action models, neural networks that let machines look at a messy room, understand a sentence like, pick up the red cup, and physically move to make it happen. Visual input, language understanding, motor coordination, all working together in real time. And this isn't a fringe experiment anymore. Tech giants and ambitious startups are pouring funding, talent, and computing power into intelligent bodies in the physical world. Robots that once stayed bolted to factory walls are now navigating real spaces, handling everyday objects, and learning from demonstrations instead of rigid scripts. Thousands of humanoid units are projected by 2026, machines designed to work alongside humans, helping with physical labor, chores, and the tasks people would rather avoid. This isn't science fiction, it's industrial strategy, it's funding roadmaps, and it's why a robot threading a needle isn't a party trick. It's the next chapter, and here's where it gets really wild. Robots aren't being pre-programmed line by line anymore. They're watching us, like students at the back of a classroom, and then doing what we do. No predefined loops, no rigid scripts, just observation and imitation. Tesla's Optimus has been shown practicing kung fu after watching a human trainer move and shift in real time. It's not remote controlled, it's not puppeteered, it learns from sight and then acts. Traditional industrial robots required engineers to specify every motor command, how far to bend, when to stop, how to grip, every detail written into code. Now, with demonstration-based learning, a robot watches a human perform a task, breaks the motion down frame by frame, and figures out how to replicate it. That's a massive leap. It's like a child watching a chef chop vegetables, learning through repetition and imitation. Optimus doesn't need thousands of manual instructions. It needs examples. This shift from code us to show us overturns decades of robotics thinking. Robots aren't just executing commands. They're learning like apprentices, observing, adapting, then acting. And just when it seemed like robots might stay confined to labs and demo stages, everything shifted again. Humanoid robots are entering real industrial environments, logistics centers, factories, warehouses. They're handling sorting, lifting, material movement alongside human teams. Picture a warehouse floor, wide spaces, buzzing activity, and humanoid robots walking between aisles, lifting packages, moving inventory. It's not perfection yet. These systems are still early, but companies see real potential in automating the dull, dangerous, repetitive tasks that wear people down. This isn't theoretical research, it's operational. Robotics isn't staying in the lab, it's stepping into the real world. And then something unexpected happens. Robots stop being a niche tech topic and become internet stars. A humanoid performing kung fu, balanced stances, fluid blocks, weight shifts that look eerily human. Millions watch, rewind, comment. How did it do that? Is this real? Then another moment. Humanoid robots practicing martial arts beside Shaolin monks. Tradition meets technology. The internet reacts with fascination and unease. These aren't polished ads. They're short clips that stop people mid-scroll. Curiosity drives it. Did that robot really adjust mid-movement? These moments reshape how people see robots, not as static machines, but as performers in a story that feels unfinished and urgent. Then the spectacle expands. Robots playing basketball, dribbling, pivoting, taking shots that look strikingly human. Watching a robot sink a jump shot is undeniably captivating, but these moments signal something deeper: balance, coordination, whole body motion improving rapidly. When robots show up in sports and performance, the technology feels alive. Engineering meeting culture. And everyone keeps asking the same question: what's next? Then came the moment that made people sit up. A humanoid robot threads a needle, stitches embroidery, live. A craft refined over generations, executed with sub-millimeter precision by a machine. For robotics engineers, this wasn't just impressive, it was a new level of dexterity. By early 2026, robots weren't just executing pre-taught motions, they were learning complex manipulation from real-world examples. Watching, processing, then doing. That's the tipping point. These machines aren't just following instructions anymore. They observe us and replicate what we do. There's awe and there's unease. If robots can master lifelong human skills this quickly, what does that mean for us? But let's pause. Not every impressive robot demo means we're living in the future today. Many of these showcases run in controlled environments, supervised, simplified, carefully staged. True autonomous intelligence in chaotic, unpredictable real-world conditions is still difficult. Battery life is limited, safety systems are evolving, reliability over long hours remains a challenge. Robots are extraordinary, but hype often outruns capability. That reality check matters. And here's the optimistic twist. Robots aren't here to erase people. They're here to take on dirty, dull, and dangerous work, heavy lifting, hazardous environments, repetitive labor. Every major technological revolution brought upheaval. Jobs shifted, industries transformed, humans adapted. Robots can dig tunnels, explore toxic zones, operate in extreme environments. But they still cannot replicate creativity, empathy, leadership, critical thinking, the qualities that define us. Robots aren't perfect yet. They face limits in power, safety, autonomy. But we're standing at a historic shift. So here's the question: what skill would you want a robot to learn next?